Hi, my name is Bailey Hatch, and this is my example question that I came up with. How long does it take for light from the sun to reach the earth? Relevance of question to topic explained. Number one, it demonstrates finite speed. Most people assume that light travels instantly, but this question clearly shows that light takes time to travel, even from our sun. This helps debunk the myth that light is instantaneous and shows that it moves at a constant speed. Two, it applies the speed of light in a real situation. The question uses the actual value of the speed of light in a simple real-world calculation. It makes the concept practical rather than abstract. And three, it connects everyday experience to physics. We experience sunlight every day, but this question reveals a hidden truth. We are seeing the sun as it was a little over 8 minutes ago. That is a powerful way to show how the speed of light affects our perception of the universe. I put a picture of Earth and the sun just to kind of show y'all what we're talking about. And I know y'all have seen pictures of the Earth and the sun, but so three kind of main points of the relevance of the question. It shows you a lot, and it may be a simple question, but it's kind of in depth and makes you realize.
Today I'm going to be presenting my example question, which is what happens to time and mass as an object approaches the speed of light according to Einstein's theory of relativity. Here I have the relevance to the question of the topic, and explaining the time dilation is as an object moves faster, time slows down for it is to a stationary observer. This means, for example, as a clock on a spaceship traveling near light speed would tick more slowly than one on Earth. And for the mass increase, as speed increases, so does the object's mass, not because it gains matter, but because it takes more energy to accelerate. Near light speed, the mass becomes so large that it would require infinite energy to go faster, and that's why no object with mass can reach or exceed the speed of light.
My question was, how fast does light travel through water? It shows that light is finite. It shows how light behaves differently depending on where it travels. And it shows us how refraction works. Refraction is the bending of light when it goes through a medium.
My name is Rudy Nunez. I'm majoring in Associates in Applied Science and Process Operating. And this is the example question, Astronomy in Space by Rudy Nunez. How far does light travel in 2.5 seconds through a vacuum? Relevance of questions to topic explained. How far does light travel in 2.5 seconds through a vacuum? This question uses the official speed of light in a vacuum. 3.00 times 10 to the 8, 3.0 times 10, 8300 times 108 ms, which is central to our topic. It applies the core concept of motion distance equals speed times time, directly showing how far light travels in seconds. It connects to real-world applications like space travel, satellite communication, and how far light goes in a blink. It reinforces the understanding that light speed is constant and forms the basis for more advanced topics in physics.
Methods of understanding the question explained. For one, it builds a real understanding of the speed of light. It's not just a number anymore. This question helps you visualize how fast light travels by connecting it to something familiar, like the sun and the earth. Two, it improves scientific thinking. Solving the question strengthens your problem solving and calculation skills using real world values. Number three, it helps you understand delayed effects in space. The 8-minute delay between the sun and the earth shows why there's a lag in space communication. This is critical in space science, satellites, and NASA. Number four, it encourages curiosity about space and time. Like questions that you might get in your head, like how long does it take light from other stars to reach us? Like, I guess you could calculate the different distances that the stars are at, like the sun, but different stars. And then another question is, are we looking into the past when we see the night sky? This is a picture of like time and a tunnel. I just thought it was pretty cool. So
Here are some benefits of understanding the question. The question, it proves that time is relative, not universal, a radical shift from Newtonian physics. It's open doors to questions about time, travel, causality, and the nature of existence.
Benefits of understanding this question: it helps us develop better cameras for underwater discovery and research. It helps us better research the human body because we are mostly made of water. It helps us better understand refraction and reflection so that better lenses and goggles are made for underwater exploring. Since light behaves differently underwater, we need better lenses and goggles that are better suited for underwater exploration.
Benefits of understanding questions explained. How far does light travel in 2.5 seconds through a vacuum? It helps visualize the incredible speed of light by turning in abstract numbers into real measurable distances. It builds skills in applying formulas, scientific notation, and unit conversions, important for all physics topics. Lays the groundwork for understanding space communication, delays, GPS timing, and astronomical distances.
process of writing this question. I started with a main topic, speed of light. Then I chose a real life example. I thought about how we experience light every single day from the sun. Then I wanted to ask a simple yet measurable question that's easy to understand but still meaningful and connected to physics. So I wanted to use the speed of light to find out how long it takes for light from the sun to reach the earth. That's a picture of the formula. Distance, speed, and time. You divide there and you multiply there. You can kind of rearrange the formula however you're wanting to. Depends on what you're trying to get. But yeah, so that's how I came about making the question. I just wanted something that you can relate it to, and it'll be easy to remember because you see the sun every day, and really it's kind of shocking that it takes 8 minutes and almost 20 seconds for the light to get from the sun to the earth.
Here is the process of writing the question that I have. What happens to time and mass as an object approaches the speed of light? For number 1, I would focus on the main topic, which is the speed of light. 2, I would pick a real world example, which could be the moon. 3, I would ask a meaningful question about the question. And 4, I would check for relevance to see if your questions about the question is relevant.
My process for writing this question was I wanted to focus on the main topic, which is the speed of light. I wanted to pick a real world example and make sure it's relevant to the topic. I picked light traveling through water because I'm really interested in the ocean and the fact that we've only discovered 26% of it. And I wanted to be able to use physics to solve it.
Process of writing questions outline. How far does light travel in 2.5 seconds through a vacuum? I wanted a question that was simple but meaningful, using real scientific data like the constant speed of light. I avoided questions that were too easy, like just stating the speed of light, or too complicated, too complex, involving refraction or relativity. I tested different time values and chose 2.5 seconds because it requires working with decimals and scientific notations.
Uniqueness of the question explained. So rather than talking about the speed of light as just a number, this question shows how it's used in real calculation with real world meaning. It also introduces the idea that light defines how we experience time and space. We never see things exactly how they are right now, if they're far away. That's powerful and unique. That's a picture of the sun behind the earth. But yeah, so it just makes you think about things like I don't know, it's like it's crazy to think that it takes like the light hitting us, or the light that we see, is already, it's been 8 minutes. It took 8 minutes for it to get here from the sun. I say just 8 minutes and 19 seconds. So I think that's unique because it's just something odd to think about. Not odd, but something you don't think about every single day.
Uniqueness of my question explained. It breaks down classical assumptions. Einstein shattered this view by showing that time and mass are relative depending on the observer's motion. It unites space, time, and energy. Einstein's equation E equals mc2 reveals that mass and energy are interchangeable and that the speed of light is the key to this transformation. Also, it has real-world and sci-fi impact. The GPS satellites must account for time dilation to remain accurate. Sci-fi films like Interstellar and Tenet use principles to explore time travel and alternate reality.
So this question discussed: how fast does light travel through water? It connects physics to real life. It's specific. It's not accident. It's not asking how fast light travels in general. It wants to know how it travels in water. Because light travels through things at different rates depending on what it is. It travels through a vacuum at a different speed. It travels through water at a different speed, and it travels through oil or something like that at a different speed. It intersects with many areas of study like medicine, engineering, and helps us study the environment.
Uniqueness of question explained. This question is unique because, unlike typical textbook problems, my question uses a non-round time value, requiring more careful math and unit handling. It focuses on distance traveled, which helps visualize light speed instead of just memorizing it. The question connects directly to real-world events like how far signals travel in space, communication. It uses the speed of light in vacuum, reinforcing the idea of a constant that defines modern units of measurement.
Relevant chart, graph, and diagram. Here's a relevant graph and diagram I made showing how long it takes light to go from the sun to the earth. So, I made this after I kind of calculated the question. There's the sun, there's a little dotted line that goes to the moon, kind of showing that that's the light traveling. It says 8 minutes and 20 seconds. How long does it take for light to travel from the sun to reach the earth? There's a graph, and it's starting at 0, and it makes its way up to 8 minutes and 20 seconds. There's a light, and that's the time in minutes. So, I put a little outline around my border, or a border around my graph. My graph and my diagram.
Slide, I have some graphs and diagrams provided to show how you would calculate the mass and the speed, and also the time. Here, as the speed increases, the mass increases as well.
This is my relevant chart. It shows everything that you'll need to solve the question.
Relevant chart, graph, diagram provided for how far does light travel in 2.5 seconds through a vacuum. The chart and how it travels.
Relevant formulas and constants explained. The main formula is speed equals distance divided by time. That's the formula I used. And there's a picture I put in there to show speed, meters per second, is equal to distance, meters divided by time in seconds. The constants used would be that the speed of light is 3.00 times 10 to the 8 meters per second, and the distance from the sun to the earth is 1.496 times 10 to the 11th meters. So those are the constants used in the formula.
Here are the formulas and constants explained. We have a time dilation formula and a relativistic mass formula. The time dilation, here is it broken down as to what symbol means. As for example, V is for velocity of the object, and then for the mass, we also have the consonants broken down as for M is equal to the observed mass of velocity, and the mass increases with speed approaching infinite near. And the time dilation equation shows how time slows down as velocity approaches.
V equals speed of light in medium, which is water. C equals speed of light in a vacuum. And N is the refractive index of water, which is 1.333.
Relevant formula constants explained. Formula: distance equals speed times time by distance equals speed times distance equals speed times time. The speed of light constant is the regular formula that we've been using. This is a universal constant for light in a vacuum. It has units of meters per second, m/s. It defines how far light travels every second in an empty space. Time given is in our question, 2.5 seconds measured in seconds, the S unit of time, why it matters. This formula and constant are the foundation for solving many problems for astronomy, communication, and physics.
Solving process thoroughly explained. So, first step, you will be rearranging the formula to be time equals distance divided by speed. Second step is you're going to gather the known values, which is the constants. Step 3 is you're going to plug these numbers into the formula. Step 4 is you're going to solve. But you would think that that's the final answer, but it's not. Step 5 is to convert the seconds to minutes. Okay, so step 1 in solving. You're going to get 1.496 times 10 to the 11th meters divided by 3.00 times 10 to the 8th meters per second. So, step 2, you're going to get 0.49867 times 10 to the 3rd. And that equals 498.67 seconds. So it's 498.67 seconds. So you're going to need to convert from seconds to minutes here. So to do that, you're going to do 498.67 seconds divided by 60. Get 8.3112 minutes. So what to do with the 0.3112? So you're going to convert, you're going to continue converting. So you're going to convert that 0.3112 back to seconds. So you'll do 0.3112 times 60. We previously just divided to get minutes, but this time we're going to times this 0.3112 by 60 in order to get the remaining seconds. So when you do that, you get 18.67. So your final answer, when you round to 2 decimal places, will be 8 minutes and 19 seconds. And that's how far, that's how long it takes from light to travel from the sun to the earth, is 8 minutes and roughly 19 seconds. Here's a picture of Albert Einstein on the chalkboard, because that's us solving the problem, it felt like.
Next is solving process thoroughly solved. I have each equation broken down for time dilation. I have it written down step by step, and I also have given you an example on how to solve the problem, and also for the math step by step, I have an example and I have it broken down of how you can multiply and divide to get your answer. And so the mass appears to increase to 1.67 kilograms in the equation that I gave due to the motion, and this is from the perspective of someone not moving with the object. And in the time dilation example broken down, so the moving object's clocks run slower and it experiences only 10 seconds within 16.67 seconds pass for the observer.
The process thoroughly described. When light travels through a medium like water, it slows down. To find the new speed, I use V equals C divided by N, which is the speed of light in a vacuum divided by the refractive index of water. Step 1, write the values. V equals C divided by N. Step 2, plug in the values, which is 299,792,458 meters per second divided by 1.333, which equals 224,900,569.1 meters per second, which is approximately 75% of the speed of light in a vacuum.
Solving process thoroughly described. Step 1, you use the formula time equals distance slash speed. Step 2, gather the known values, constants. Step 3, plug these numbers into the formula. Step 4, solve. Constant, speed of light. Value 3.00 times 1063.00 times 10,883.00 times 106 meters per second. Meaning this is the exact speed at which light travels in a vacuum, a fundamental constant in physics. Units, meters per second, showing distance traveled every second. The distance is 750 million meters, or 750,000 kilometers. Solving. Identify the formula using the basic motion formula. Insert known values of speed of light. Perform multiplication, multiply the numbers. Step 4, interpret the result.
Solution correct and applicable to the topic. Yes, this solution is correct. It takes around 8 minutes and 19 seconds for light from the sun to reach the earth. Yes, this is applicable to the topic. This shows how fast light travels across vast distances and helps us understand the scale of space and time, meaning of speed of light. So, I mean, I guess if you don't know, you do now, that it takes 8 minutes and 19 seconds for the light to reach the earth from the sun. There's a picture, another picture. It's different, but it's another picture of the earth and the sun.
A solution compatible to my question, what happens to time and mass as an object approaches the speed according to Einstein's theory. For the mass increase, as speed increases, the object's relativistic mass increases as well. It effectually becomes heavier from the observer's frame. This increase makes further acceleration harder, requiring infinite energy to reach speed of light. No object with mass can achieve or exceed the speed of light. And for the time dilation, as an object moves closer to the speed of light, time slows down for the object relative to a stationary observer. And this phenomenon, called the dilation, means that astronauts on a near light speed voyage could experience just a few years while centuries pass on Earth.
This solution is correct because we know that the speed of light is 299,792,458 meters per second in the refractive index of water. The refractive index definition is N equals C divided by V. This solution is applicable to the topic because it confirms the universal speed limit and shows the relationship between light and matter.
Solution correct, applicable to topic. Correct. The correct answer for 2.5 seconds equals 0.04117 minutes. About 2.5 seconds is roughly 4.117% of a minute. It takes 0.0417 minutes for light to travel through a vacuum. This question explores the speed of light by calculating how long it takes for light to travel through a vacuum using the speed of light and the average distance from the 100 kilometers. This shows how fast light travels across vast distances in space and helps us understand the scale of space and the meaning of speed of light.
This happens because water is denser than a vacuum, so the light interacts more with the particles in the water, which slows it down. This slowing of light is what causes effects like refraction, when a straw looks bent in a glass of water. So that's why I included a picture of a straw in a glass of water, and I'm sure that everybody has seen this before. You throw a penny in the water. Anything in the water looks differently than when you pull it out of the water, and that's refraction. And that's because the light travels at about 75% of its speed in a vacuum. So, interesting. Valuable information explained. In water, light travels at about 75% of its speed in a vacuum.
The next slide is additional valuable information. A fact is that in black holes, gravity is so strong that even light can't escape out of a black hole.
High-speed signals still take measurable time to travel through fiber optic cables and computer chips. This has a lot to do with internet speed.
Additional student interest described. One of my favorite, mind-blowing movies is Interstellar. And that's a picture of the movie cover of Interstellar. Let me freaking just start this over. Additional student interest described. One of my favorite, mind-blowing movies is Interstellar. And that's the picture of the cover of Interstellar. If you've never seen it, you should definitely watch it because it literally blows your mind. But it also makes you think, is the speed of light the fastest thing, or could there be something else that's faster? I don't know, but if you've never watched it, you should definitely watch it because it will raise some questions in your brain about how these sort of things work, if it is at all possible. It makes me wonder if anything can actually travel faster than the speed of light, or how that would even be possible. So, time travel and sci-fi kind of makes me interested to see how they're saying this is happening, but hasn't came out yet. But if there was time travel.
In this slide, I have an additional interest which caught my eye during this whole presentation. which was the GPS technology and how GPS uses the speed of light. And so GPS is one of the few technologies where Einstein's relativity isn't optional, but it's very essential. And without correcting for time dilation and gravitational effects, GPS would be off by up to 10 kilometers per day. The GPS satellite sends signals that travel at about 299,792 kilometers per second, the speed of light in a vacuum. Your GPS receiver calculates your position by measuring how long these signals take to reach you. GPS systems have been used to test the constancy of light speed, a core idea in special relativity. They confirm that light travels at the same speed regardless of the motion of the source or the observer.
Additional student interests described. This topic interests me because I'm very into underwater exploration YouTube channels. I like to watch them see fish that we've never seen before. This also goes into the fact that only 26.1% of the ocean has been mapped out as of June 2024, and only 10% of its species have been found, leaving millions to be undiscovered.
Additional student interest described continued. Superheroes and comics. The Flash is a DC comic TV series. His power runs faster than light. Consequences, time travel, alternate realities, paradoxes. Teaching hook. Is it even physically possible to run faster than light? Introduce continuity and relativity. Marvel's Quicksilver, X-Men. The Scene, Pentagon Kitchen slow-mo run. Teaching hook. What would it feel like if you move near the speed of light while everything stood still?
Overall summary of the topic presented. The speed of light is the fastest anything can travel. It is nature's speed limit. According to Einstein's theory of relativity, even gravity and information can't go faster than light. This speed shapes how we understand time, space, and the structure of the universe. So it's talking about universe, so I kind of put Earth and space. That's just my portion of the summary. Nothing can travel faster than the speed of light. It's the fastest thing, and if it can, then we're touching into some new science.
Summary of the topic presented. Speed of light is used in everyday technology. Light speed signals power fiber optic, internet, GPS, space communication, and more. It's essential for modern life, even if we don't notice it.
So, relevant sources for all information provided for the project. Here are some of the sources we used for an entire project. So this is just one page. I made 4 for each of us, but as you can see, there's a lot. I'm just presenting my slide, but there is a lot of sources that we used, and I do appreciate you.
And here are just a few of the sources that we use for the information in all of our slides. We do have about 3 or 4 pages full of sources that we've all used to get the information to be put onto our slides.
This is my relevant sources for all information given. And if I click this will take me to find the refractive index number of water, which is right here, which is 1.3325, but I rounded up to 1.33.